Today's topic is going to be OSI model or OSI architecture. OSI is an open system interconnection which is developed by ISO in 1984. So, why we need an OSI model and what is an OSI model? For example, I am communicating with my friend. I need to send a message to my friend. So, the process of overall communication needs some model or architecture that is called as OSI model. It is not that we only use OSI model for the communication. We also use TCP/IP protocol, etc. So the overall communication, how to facilitate communication between different systems is the OSI model. And in the OSI model, we have 7 layers, whereas in the TCP/IP protocol, we have 5 layers. So the 7 layers are: first is application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. These are the 7 layers. But in the TCP/IP protocol, these 3 layers are combined together and forms the application layer. And we'll see the uses and what are the work of each layer in the upcoming slides. And at last we'll see how the data is sent from the sender to the receiver once we know those uses. Let's start with the layer. So now we are seeing what is physical layer. Physical layer is the bottom layer. It is the lowest layer of the OSI model. This layer is mainly used for the physical connection between the devices. It may be any devices, and the physical connection between them is through the physical layer. And here the data is in the form of bits. The data which we send will be finally in the form of bits. Bits means it is in the form of zeros and ones. So once the data is in the form of bits, and then it is moved to the sender's physical layer through a transmission medium. It may be any physical medium, any LAN or Ethernet cable, whatever it is. Next is going to be our data link layer. The key point why we use data link layer, or why the data link layer is used, is for error free transfer of data frames. Once the data reaches the data link layer, it will be in the form of frames. So the data message is converted into the form of frames. In the frame we have different source address, destination address, etc. So the address will be in the form of MAC address. So, have you heard of the term MAC and IP? Yeah, MAC address is the address of a computer. IP address is the address of the network which we are using right now. So, data link layer is uses frames and uses MAC address for their communication. The data link layer is divided into 2 sublayers. One is logical link control and the other one is media access control. The first one is logical link control and the other one is media access control. In logical link control, the communication between the network layer and the MAC takes place. So the frames are converted into, sorry, the frames is moved to the network layer through logical link control, and MAC provides a connection between the logical link control and the physical layer. So MAC is used for that. MAC address is obtained by ARP. ARP is Address Resolution Protocol. So our next layer is going to be network layer. Network layer is used for the transmission of data from one host to another in different networks. It may not be in the same network. It may be in different networks. So for that we use network layer. In network layer, the data is in the form of packets. Here the data is converted into packets and it uses IP address for its packet forwarding. So in this network layer, routing takes place. With the help of packet routing, the layer will be able to find the shortest path to transfer the data. So the protocols that are used to route the network traffic. So for network traffic, to route the network traffic, we use network layer protocols. And there are many different types of network layers protocols. One is IPv4, we use IPv6, etc. The next layer is going to be transport layer. From the name itself, we will be able to understand that it takes care of the overall transportation. So how the data is sent from the starting to the end. And also it ensures that the data is transmitted in the order and there is no duplication of data, which is very important. And then the data in the transport layer is in the form of segments. As we have seen in data link layer, it will be in the form of frames, and then network layer, the data will be in the form of packets, and in transport layer, it will be in the form of segments. So the data will be segmented or separated into different contents, and then the process starts. It is responsible for the end-to-end data transmission service, as I said earlier. In the transport layer, we have two protocols. One is going to be transmission control protocol and the other one is user datagram protocol. In the transmission control protocol, the sender and the receiver will be keep track of the data they have sent, and the acknowledgement message from the receiver will come to the sender. Once the message is sent, the receiver will acknowledge that the message have received. But in the user datagram protocol, the acknowledgement process does not happen. This is the major difference between the transmission control protocol and user datagram protocol. So as we have said, in the session, from the session layer we get data for the presentation layer, and once the data is given, it is fragmented into segments and then it is moved to the network layer. This is all about your transport layer idea. The next layer is going to be session layer. The session layer takes care of the overall sessions, when the connection have been started, when it is terminated, how long it takes for the message to transfer, and also it ensures the security of the data that is being sent. It always takes security as its primary goal, and it has some of the features in this. The first is going to be connection establishment. Connection establishment is how the from where the connection have started, when the session started, it all takes care of, comes under connection establishment. Connection termination is when the session is ended, when the message is reached. And synchronization, whether all the send message, receive message are all in the sync, and overall dialogue control. So this is the major features of the session layer. Next is going to be presentation layer. So presentation layer is also called as translation layer. Here the data from the application layer. So for in the presentation layer we get the data from the application layer. So here the data is manipulated in the required format. So how the data need to be transmitted in the format, the presentation layer converts the data over the network, and it is also takes care of the syntax and semantics of the information. So the overall format is taken care by the presentation layer. Here the data is decoded, decrypted, encrypted, composed, compressed in all the necessary things for the data to be transmitted over a format is done in the presentation layer. From the application layer we receive the data, and it is encoded, encrypted and composed in the sending side. In the receiving side it is decoded, decrypted and decompressed, and then it is sent to the application layer. And the final layer is called as application layer. So this we say it as the topmost layer. When in the receiving side, the data is got only through the application layer. It is one of the very important layers. So these applications produce the data which need to be transformed through the overall network. It provides an end-to-end services and also to the end users. Here the main function is FTAM, that is file transfer, access and management. So this is the main part of the application layer. Here the user sends any format or any kind of data and then the user receives it in the format which is sent. This is the overall process of the OSI model. Now, now we'll see the architecture diagram once again. So this is the OSI model architecture which we have seen in the first slide. Now we have seen all the concepts of the layers, how each layer works. In this, for example, now let's sending a message. A sender is sending a message. It may be, the message may be either a video, audio, text, or whatever it is. Here let's take hi with that emoji. The sender is sending a hi message. In the application layer, it will be in the form how the sender sends, and after the application layer it is moved to the presentation layer. In the presentation layer, as we know, the data will be formatted as the need of the network. So here the data may be encrypted or compressed, whatever, how the format is needed. And then it also makes sure the security of the data and ensures that no data is lost. After the presentation layer, the data is moved to the session layer. So the session layer tracks the session when the message has started sending, and when it finishes. Everything will be noted in the session layer. After the session layer, it is moved to the transport layer. Transport layer is responsible for the overall transportation of the message. So in the transport layer, the compressed data is made into segments, which will be of segment 1, segment 2, how much data we have given, it will be fragmented into those segments. After the segments, and also in the segment, we have two, in the transport layer, we have two protocols. One is TCP and the UDP. So it makes sure that all the messages sent and there is no data lost or no duplication of data. After the transport layer, it moves to the network layer. So network layer sees how the data is sent from one host to another in a given network. And also here the data will be in the form of packets. So the packets will be have a header, source address, destination address, and the data. Here the source address and the destination address will be in the form of IP address. Source address will be sender's IP address, and the destination address will be receiver's IP address. After the network layer, it is moved to the data link layer. In the data link layer, it will be in the form of frames. So here frames uses MAC address. So source address will be sender's MAC address, destination address will be receiver's MAC address, and also it has an error control in the frame. Then it is moved to the physical layer. So the frames are converted to bits, that is zeros and ones in the physical layer. This is going to be the last layer. After this, it is moved to the physical layer to a transmission medium. So the transmission medium can be either a LAN or Ethernet, whatever it is. Through the transmission medium, it is moved to the physical layer. In the physical layer, the bit will be in the form of zeros and ones, and then it is moved to the data link layer, which will be converted into frames, and then to network layer, which will be converted, the frames will be converted into packets, and from the packets in the transport layer, it will be converted into segments, and session layer keeps the track of the session, and the presentation will decompress the data and decrypt the data which is encrypted, and then make sure that the messages which is sent by the sender is have been arrived and no data loss have taken place. And after the presentation layer, it is moved to the application layer. In the application layer, we'll have the data in the format which is sent by the sender. For example, hi with an emoji, that will be displayed in the application layer where the receiver can see the data. So this is the overall flow of the OSI architecture model. Thank you.